In this video, we'll discuss functions. Now, a function is a rule that assigns exactly one output for each allowable input. The domain represents our allowable inputs, which are our x values, and the range is the outputs created by that domain, which we consider the y values. We can represent functions through function machines, tables, graphs, and often there will be some equation for most functions that we will deal with. Now, when we're creating a table, we're going to use the left column to represent our domain, our inputs, and our right column to represent the range, our outputs. Say we have a function called the doubling function, where the output is double the input. As an equation, this would be written as f of x equals 2x. That means when we consider our input, that will be our x values, and f of x will be our output. So let's say we input 2. The output would say 2 times 2, which is 4. If we chose 5, that would be 2 times 5, which would provide an output of 10. If the input had been 12, that would be 2 times 12, which puts an output of 24. If it had been 33, 2 times 33 would have created 66. If it had been 51, that would have been 2 times 51, which is 102. Because there's no restrictions given for the domain, we could choose any value for that input and create its corresponding output in this table. Now, if we wanted to graph, we'd be working with the coordinate plane, which is a plane of two perpendicular number lines that intersect at the location of 0 on the number lines. Our x-axis will represent our horizontal number line, which is often where our domain is considered, and the y-axis is the vertical number line, which is where our range is considered. The coordinates on this coordinate plane are locations of points, and then we typically write them as x, comma, y. The origin is a very specific location. That is where the two axes intersect, which is at the points 0, 0. Now say you wanted to plot a point, say point A at the ordered pair 4, 3. We would start at the origin, we would move 4 units to the right, and then we'd move 3 units up, and that is where point A would be located. Now the graph of the function will represent all the ordered pairs whose y value is the output of the given x value. When we construct that graph, we want to create a function table to help us. We can list inputs that help us create integer outputs whenever possible. Then we're going to plot those ordered pairs from the table and then draw the appropriate line or curve through the ordered pairs. How many points we need to create is dependent upon the line and the curve to help us get the best fit of that function. Now let's go back to that idea of the graphing the doubling function. We said that equation was f of x equals 2x. Now comparatively, before I just used any inputs to show that it would double to create the corresponding output. When we're graphing, it's helpful to try to stay near the origin and use inputs that will create integer outputs whenever possible. So let's use some negative and positive values. So say we use -1. That will create an output of -2. So that gives me the ordered pair -1, -2. Then I could use 0, and that would create the ordered pair 0, 0. If I did 1, that would create the ordered pair 1, 2. If I did 2, that creates the ordered pair 2, 4. And 3 would create the ordered pair 3, 6. I have all of these points, and I can see that that is forming a line because this is a linear function. So I can draw the line straight through those points, and that would be the graph of the doubling function. Now, if I have a linear function, the graph will always be a line. And since it's a line, I can graph it with exactly 2 points. But this is only true if it is linear. So if I can choose 2 inputs that create integer outputs, I can then draw the line through it relatively easily. A very helpful input is x equals 0 because this constructs the y-intercept of that linear function. So let's look at this function, f of x equals -1/2 x plus 3. If I put an input of x equals 0, my output would give me -1/2 times 0, which would be 0 plus 3, and that's 3. So I can plot that ordered pair. That is the y-intercept. Now I'd want to choose a second point that will give me an integer value. So I want it to be a multiple of the denominator. That's a way to think about it. What's a multiple of the denominator? Well, let's use 2, because negative 1/2 times 2 is negative 1. Negative 1 plus 3 is positive 2. That will give me an ordered pair of 2, 2. Now I have 2 points. I know it is a linear function, so I can draw the line through those 2 points, and that will represent all of the values that make this function true. Now we can also use the graphs to interpret and analyze given situations. Say that we have this function where we have the bush's height since the day it was planted, and the height is in feet and the time is in months, and we have it up to 16 months since it was planted. First thing you'd ask, when did the bush begin to grow? So if we look and we follow our graph from left to right, because this is time 0, if we see it starts to take off, then we get to month 3, and then the graph starts to go up. The height begins to go up. That means the plant is starting to grow at that point. So between months 3 and 4, the bush began to grow. Now, another question could be, between what 2 months did the bush grow the most? So we want to look for places on this graph where the slope is greater. Where does the line look like it's steeper? So let's choose some of the more steep locations. So between month 8 and 9, if we look, that's a height growth of about 1.5 feet. Between 9 and 10, if we look, that's another about 1.5 feet growth. But then if we go between 10 and 11, we look and say, this goes up 3 feet. That is our greatest growth. So between month 10 and 11 is the greatest growth of our bush. Now, when did the bush stop growing? We're looking at it grows, we know starting at month 3, and we're looking where does it just plateau and level off and not get any taller, where the height doesn't go up anymore. And if we look left to right, when we get to month 14, it then flatlines. That means it stays at that height of 12 feet. So our last question then, what is f of 12 and what does it mean? F of 12 means go to month 12 and then look at what's the corresponding output. What is the y value on there? So we can go up and say, well, if I look at that, f of 12 is reaching 11. That means that after 12 months, the bush is 11 feet tall.